today we're going to be looking at how mixtures can be separated, and we're also going to look at chemical and physical properties. So if we look at mixtures, I want you to think back to the previous video that you watched, and it said that mixtures can be separated. So there are a few different ways that you can separate a mixture. And the first one is really common. You have, in this case, coffee grounds that you are keeping separate from the water that flows through them. You have maybe a strainer at home that you separate the water from the macaroni and cheese that you might be making that night for supper. We call that filtration. So when something is filtered, you're taking the solid piece from the liquid, because this would have been a heterogeneous mixture like our muddy water that we had in the previous example. So that would be one way. If you have a solid and a liquid, you can use the filtration system. Doesn't always work that way though. Sometimes you have two liquids. So another way that we can separate mixtures is by distillation. And this separates two different liquids, or it might be a solid particle that's been dissolved into a liquid, but just running it through a strainer isn't going to work. So this is what a distillation process looks like. And the way this works is based on boiling point. The particles that you have, maybe let's say salt water, for instance. Salt is a solid dissolved in the water, and water and salt boil at two different temperatures. So what happens is you put some type of heat source underneath your salt water mixture, and the water is going to the water is going to boil first. So you can see the little bubbles creeping up here into the top of our flask. And as the water is boiling, as it creeps up here to the top of the flask, the further away from the heat source it gets, starts to cool down. And so it condenses or turns into a liquid again here on the edges of the flask. And then that runs down into this tube, and you can collect your pure water over here. And eventually over here you would have nothing but salt. That's how submarines, as they need fresh water, they actually do this process to take that salt water and convert it into good drinking water. So a liquid can be boiled. Again, it produces a vapor, and that vapor condenses into a liquid and can be collected separate from the original mixture. Now, let's look at properties. Okay, we're going to look at physical properties first, because there's more physical property examples than chemical. Physical properties are characteristics that you can observe about a substance or about a mixture. You could measure them. So it can be using your five senses, or it can be quantitative, actually measuring it. So some examples would be the density, shape of it, the mass, the size. What state of matter is it in? Is it a solid, a liquid, or a gas? The color of something, and then viscosity. This picture is showing the viscosity, and this is how something flows. The thicker it is, the harder it flows, and so you have things like water that flow very easily, and then maybe you get into like syrup, molasses, all the way into gels, which don't hardly flow at all. So those are some physical properties. And physical properties can be divided up into two different types of physical properties. The first one is called intensive properties. These are ones that it does not depend on the amount of matter you have. The property would be the same whether you had a large amount or a small amount. Some examples would be boiling point. If you take a huge container of water or a small container of water, does not matter, the boiling point of water is still 100 degrees Celsius, and it will boil at that temperature regardless if it's small or large amount. The density of something, the color of it, melting point would be another. Wouldn't matter for ice, hard, solid, H2O. Small amount, little amount. The melting point is still the same regardless. And then you have extensive properties, and these are ones where it does depend on the amount of matter that you have. For instance, if you wanted to measure the length of something, you wanted to measure the mass or the volume, those are going to change if you have a small amount or a large amount. the mass will be different, the volume would be different, the length would be different. So those are extensive properties. When we look at chemical properties, we're looking at its ability, the substance's ability to change, to chemically be altered. This is how we can identify different substances. And you're not going to notice a you're not going to notice a chemical property unless you're observing it actually going through a chemical change. Whereas physical properties, you can look out at the room around you and list off a bunch of physical characteristics. Chemical properties you're not going to see until it's actually going through a chemical change. So for example, the ability for something to burn. As it's burning, it's chemically changing, and so the flammability of it, if it's able to burn or not, is a chemical property. Another common example in chemistry would be its ability to react or combine with other substances. Not everything is going to chemically react, but some things will and some things won't. Some things react with water, other substances do not. So its ability to react would be another type of chemical, would be a chemical property. Now I want to look at the phases of matter, because we're going to eventually be looking at physical changes and chemical changes, and the phase of matter is going to be important for our physical changes. So phases of matter, we have gas. Okay, the gas phase, we have no set volume. The amount of gas is going to fill up however big of a container you give it, and there's no set shape. Again, the gas will take up whatever size container, whatever shape of container you provide it. So we would say that gases are fluid. That means that they can flow, they move around. Take a look at the picture, notice the arrows. That's showing the direction of the movement. Gas particles are not going in all the same direction. They bounce off the container, they bounce off of each other. They're very random, okay, in the way that they flow. And gases are the only one of the three that are really compressible, meaning that you can force the gas into a smaller container and it will fit into the smaller container. Now that might adjust the pressure. You're increasing the pressure of the container, but the gas could fit into something smaller. Let's take a look at liquids. How are they different? Notice that the liquid particles here still have some movement. There's some room in between the particles, but they're not expanding to fit the whole container. Look at all this empty space up here. The liquid particles stay relatively close together, close to each other. So unlike gases, they can't take up the whole volume of space that you give them. Okay, they have a set volume, but there is no set shape. This is why twisty straws are so much fun, especially for maybe little kids, maybe you too. But you suck that liquid up through there and it takes the shape of the straw, and so you get all sorts of fun shapes. Kids love those. No set shape for a liquid. It takes the shape of whatever container you put it in. We would also say that liquids are fluid. Fluid doesn't mean liquid. Fluid just means that it flows. It has the ability to move. And so liquids and gases are both considered fluids. Not really compressible. There's a little bit of space in between these red spheres here in the picture, so that you can compress it a little bit, but not very much, not like a gas. And then lastly, our last phase would be solids. And solids have a set volume. They also have a set shape. So here's a specific solid. A lot of the times they'll form crystals. And so you have these particles that really, no arrows, they're not moving very much at all. And they are not fluid. They do not flow, unlike liquids and gases. And they are incompressible. You cannot force these particles to get any lower. If you press on a solid to force it to get into a smaller space, depending on the type of solid, maybe it bends, maybe it breaks into pieces, but you cannot compress it down into a smaller container.